atmospheric refraction, it is a refraction phenomenon that we see in the atmosphere. Okay, so why that happens? Because the each layers of the atmosphere, they will have different densities of air. So because of this, what happens? They act as different medium. Hence, there will be refraction. So that we call it as atmospheric refraction. So because of atmospheric refraction, we see the many phenomena in the nature. One is the twinkling of stars. That is, stars twinkle, right? So that is also due to atmospheric refraction, what we see. And objects on the what we see like stars, planets, all these, they are we feel that they are still far than the actual distance. So that is also due to atmospheric refraction. Okay. Now about the twinkling of the stars. Now we'll study about the twinkling of the stars. We'll just write some phenomenon. Some phenomenon based on atmospheric refraction, based on the atmospheric refraction. Okay. First one, it is the twinkling of stars. Twinkling of stars. So twinkling of stars, why it happens? Twinkling of stars. Twinkling of stars means what? It sometimes it will be bright, sometimes it will be light, will be not so bright, right? Dull, like that. It will change. Basically, the intensity of the light of that we feel it is changing. That's why we call it as twinkling of stars. Okay, why the twinkling of stars will happen? We'll see. The stars are very far from us when compared to even the planets also. The stars are very far from us. Stars are very far from us. So when we see the stars also, it looks like it's a point sized. For us, it looks as point size because we know when the objects are very far, it looks very small for us. Correct? So the stars are so far from us, it looks as a point sized object. It looks like a point sized object. So light coming from the point sized object. Now it is like for our eyes, light is coming from the point sized objects. Okay, so due to atmospheric refraction, the amount of light that reaches our eyes from the star will vary continuously. The amount of light that enters our eyes from the star, when you see the stars, that will vary continuously because of atmospheric refraction. Okay, it will vary continuously because of the atmospheric refraction. And since it is point size, there is no way of averaging out, is not there. Averaging will not happen because we feel it's from point size it is coming. Sometimes the amount of light that enters our eyes will be more, sometimes it will be less. So that's why we feel that stars are twinkling on in the sky. Stars are twinkling in the sky. Because twinkling means what? Sometimes it will be too shiny in nature. Sometimes the light will be dull, like that, right? Whenever it is bright, we feel it is, we can see very sharp thing. Where sometimes it becomes dull, like that. So that variation is because of the amount of light that enters our eyes will vary. And since we feel that it is a point sized, the light will not average out there. Okay, so this is about the twinkling of stars. And then about the planets, if you consider, planets are nearby to us, even though planet size is small when compared to stars, correct? But planets are much more nearby to us when compared to stars. Planets are much more nearby to us when compared to stars, correct? So planets look the little bit bigger in size. Planets look little bit bigger in size when compared to stars. So what happens that time? The light, we feel that the planet is not a point size. What is that, Tula? Hmm? We feel that planets are not the point-sized objects. Okay, so it is an object where it has. We can think that it is having a lot of points, right? Like light is coming from the different points of the planets. Okay, so what happens there? Even the light from the planets also will undergo refraction of light, atmospheric refraction, but since we are receiving the light from the different points, what happens? The total light, it will average out. From one point, we feel like the amount of light is more, from one point, it is less. So, as it averages out, we don't feel the planets are twinkling, but we feel that stars are twinkling. Okay. So again, I repeat, the planets are for us. Planets looks bigger size, not as a point size. It looks as a bigger size when compared to the stars. But actually, planets are of smaller size when compared to stars. But for us, it looks like planets are of bigger size, not the point source of light. Okay, because they are much nearby when compared to the stars. Okay, so the light from the planets also there will be atmospheric refraction because the light also comes through atmosphere only. The light also comes through atmosphere only, but since from different points we are receiving the light, what happens? The they average out. From one point we get more light, from one point we get less light. Because of that, they average out. That's why we don't feel like planets are twinkling, but we feel that stars are twinkling. Okay, so for this phenomenon, what is the reason? It is about atmospheric refraction. MCQs also they will ask, sometimes they ask to explain 2 mark question. All this they may ask in this. Okay. Huh. What? See, planets are of larger size and much closer to Earth. They are not comparing with star actually here, but they are of larger size and they are closer to Earth. But stars, actually, if you see stars, sun is a star, right? Mid-sized star. But sun is bigger when compared to planets. And sun looks large also because it is nearby. Other stars are very, very far from us. And in the sky, we have stars which are very much bigger than sun also. We have lot of stars which are much bigger than sun also, but they are very, very far when compared to sun also. That's why they look it as very small point sized. Hill only, if you see from the large distance, it looks small only, right? When you go near to that, it feels very big. You can see that same thing. Planets are only actual size. If you consider, planet size is less when compared to stars, but when you compare with the distance, planets look bigger because they are very nearby compared to stars. Okay, that's right. Here also they have not compared, they have just told it is large size like that. Okay, and much closer to Earth than stars. They can be considered as a collection of large number of point-sized source of light. Yeah. Okay. Write down this. Twinkling of stars. Tejasri, you can see the screen?
Yes, ma'am.
Okay. Twinkling of a star is due to atmospheric refraction of starlight. Refraction of starlight. As the light from the star enters the Earth's atmosphere, It undergoes refraction due to varying optical densities. Optical densities. Densities of air at various altitudes. Okay. The continuously changing atmosphere, continuously changing atmosphere refracts the light by different amount. It refracts the light by different amount. The star, the light reaching reaching our eyes increases or decreases continuously. And hence star appears as twinkling twinkling at night. Twinkle at night. And next part, right? Planets do not twinkle. Planets are closer to Earth than the stars. They are closer to Earth than the stars. Hence, they can be considered as a collection of large number of point-sized sized source of light. They can be considered as large number of point-sized source of light. That is, from different points we are receiving the light. We can consider like that. So from each point, it will, from one point we get more light, from one point we get less light. As a whole, it averages out. Okay, so that is why planets do not twinkle. Hence, they can be considered as a collection of large number of point-sized source of light. Okay. The total variation in the amount of light, entering our eyes, from all these individual point sized sources will average out which nullify the twinkling effect, which nullifies the twinkling effect. twinkling. Okay. Now, the next one, the stars see higher than they actually appear. What is the reason? So this is also, see, the stars looks farther as compared to the actual distance. Okay, so what is the reason? The one reason is the atmospheric refraction. So usually the what happens in the atmosphere, the densities in the upper layer of the atmosphere, densities of the air will be less when compared to the lower layer of the atmosphere. So the density of the air keeps on increasing from layer to layer. So what happens? Optical density also, when you compare at the upper layers, it is the light will travel faster when compared to the lower layers of the atmosphere. So we studied, do you remember refraction? We studied when light is going from rarer medium to the denser medium, how it will bend? Yeah, towards the normal it will bend. So here also, it from each layer to layer, it bends towards the normal. Or the variation in a layer also, it may act as the two layers, okay, two medium. So there what happens, it tends to bend towards the north. So for our eyes, it is farther when compared to the actual distance. Okay, shall I clear this? For example, star is like this. Okay, so it tries to bend towards the normal here. Hmm. And every time it tends to bend, every time it tends to bend towards the normal. Okay, it tends to bend every time. So actually, the star, it for us, it looks farther. How to say, straight line you should draw. Hmm. Hmm. To draw. See, it will not go straight. It tries to bend towards the normal, right? Huh. Huh. See, every time it tries to bend towards the normal, right? So what happens? We feel that if you draw a straight line, whereas from the straight line, we feel the light is coming, right? If you try to draw we feel that actually star is here, but the apparent distance will be different. That is, we feel that star is just a little bit above the actual distance is there because it is trying to bend every time towards the normal. Why it bends every time towards the normal? Because the density will vary and densities will increase as the atmosphere layer keeps on coming down. That is the reason it bends towards the normal. So when it is bending towards the normal, when you draw the straight line, and if you see, for us, we feel that light is coming from the straight line, right? So when we feel, for the eyes, it feels that star is little bit above the actual distance. Okay, so this is also the phenomenon is due to atmospheric refraction. This is also due to atmospheric refraction. Right. In this part also, at least one question it will come from these portions, what we are studying from yesterday. It will come. MCQs also, they can they will give, they will ask whether it is scattering of light or atmospheric refraction, Tyndall effect, something like that. They give dispersion of light. So you have to take which phenomenon it happens like that. Okay, write down the stars higher than they actually are. Than they actually are. As the light, as the light from a star enters the Earth's atmosphere, Earth's atmosphere, enters the Earth's atmosphere. It undergoes refraction. It undergoes refraction and bends towards the normal and bends towards the normal. It bends towards the normal. Therefore, the apparent position of the star is slightly more, it is slightly more or different from its actual position. From its actual position. Hence, stars appears to be slightly higher, than its actual position, next, about advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. Okay. So this is also the same way how the stars looks more, no? It looks a little bit higher as actual distance it is there. Same way it happens for the sun also. So sun looks a little bit in the more height as it actually is there because of atmospheric refraction only. So when it is little bit more, so sunrise will happen little bit earlier itself, right, for us. Because sunrise, why it happens actually, we feel sunrises, sunsets, all this because Earth is revolving. The position between the sun and the Earth, we feel that it is rising, its sunset is there, all this will happen. So, what we actual sunrise to the time will be after like 2 minutes earlier itself, we feel that there is a sunrise, and 2 minutes delayed, we feel that there is a sunset. Why that happens? See, sun is here means we feel that sun actually we feel that it is in more height like this. So what happens? We since 2 minutes early itself we feel that it is in a higher position. Then naturally the sunrise will be 2 minutes earlier for us. Correct? No, that is the reason. Then the sunset delayed. Yeah, the sun will be more higher as it actually is there. For us, it appears little bit higher as the actually it is there, its position. So if still it will be there, but sunset would have been done. So still it is in higher position. We can see the sun. So for that to go still far down, it will take 2 minutes more. Correct. So that's why we will have the delayed sunset. So this is also due to atmospheric refraction only. Because of atmospheric refraction, what we see, we feel that apparent distance of the sun is more as compared to the actual distance. Apparent distance means what we see. That is the apparent distance. That is actually more as compared to the real distance. So what happens? Still, the sun will be above itself. For the sunrise, if the sun is here, we feel that it's a little bit above. So the advanced only we feel the sunrise is there, 2 minutes advanced. There are delayed sunset, it would have gone down sun, but still we feel it is still higher. So the delay will be there with the sunset also. So that is also the same. Atmospheric, see, sunlight passes through the different layers of the atmosphere. So each layer, what happens, the density of the atmosphere will vary. Okay, they will act as different medium. So always what happens in the above atmosphere, upper layers of the atmosphere, densities will be less. That means light can move faster. But as it comes nearer to the earth, the atmosphere density will be more. So it will go slowly. So it's like going from one medium to the other medium. So whenever it's moving from one medium to the other medium, then there is refraction of light. So here also same, it's refraction of light. And it on most of the time it bends towards the normal. Why it bends towards the normal? Because rarer to denser. So upper layers are rarer. As it comes nearer to the atmosphere layers are denser. So that means light travels slower. So it bends towards the normal.
Some have thought that if the sun is destroyed, we will not know it for 8 minutes. Because we will still be getting the sun rays. Why is that so?
See, sunlight will take 8 minutes to reach us. Sunlight will take 8 minutes to reach us. That's why they would have told. But what they will tell is when the sun destroys the mid-sized stars, no, they will expand. When they expand, it will actually swallow the earth. They tell. What? Trillions of years only. It is not now. They say now it is a mid-sized and it is in middle age. Stars also will have. Yeah, stars also they say that, new stars will be born. They will grow after long time. It will also will either it will expand, it becomes a black hole, or it will just expand so much that it will become into pieces like that. They will tell, but its duration is very much big when compared to ours. Okay, billions of years will be there. Now they say that stars are middle aged. Now the sun is a star which is middle aged. So when it is like at the end of that sun age, then what happens? It will increase. The size of the sun will increase so much because of its gravity. It will try to pull all the planets inside that. They say that how much true we don't know, but they say like that. Ah. Black hole, they tell. When star is very big, then they say that it becomes a black hole. Black hole means it will swallow everything. It is so thick that even the light that enters that will not come out. That's why you can't see that. They say it as black hole. Like that. And the light rays to reach from sun to the earth, it takes 8 minutes. So that's why they would have told like that. Okay. And now advanced sunrise and delayed sunset. Write this. The sun is, write down, the sun is visible to us about 2 minutes, about 2 minutes before the actual sunrise, and about 2 minutes and 2 minutes after the actual sunset. After the actual sunset. This is because of atmospheric refraction. This is because of atmospheric refraction. The sunlight coming from less dense to more dense air. Hence, it refracts downwards. That is, it bends towards the normal. Towards the normal. So because of this, the sun appears to be raised above the horizon.
Instead of less dense to more dense air, can we just write rarer to more dense?
You can write. It's the same. Rarer to denser. Sun appears to be raised above the horizon.
I mean, that's the same thing happening with moon. So exactly what we see there.
Little bit far. You can write hence. Sun can be seen 2 minutes earlier. Hence, sun can be seen 2 minutes earlier. This also right. Similarly, due to atmospheric refraction, the sun can be seen for about 2 minutes, even after the sunset, sun has set below the horizon. Horizon means it is the farthest point you can see, like they say, the sky and the earth where they touches like that. Horizon means it is the farthest point you can see. Like for example, in the sea, you will see the sun, right, rising at there. We feel like it is in the farthest point. We are able to see that. That only they call it as horizon. Horizon means that. Like that they call it as horizon. What is that? Okay. So until now, what and all we studied, it is about atmospheric refraction. Okay, so because of atmospheric refraction, what and all we saw, first one is the twinkling of stars. Stars, we feel that it appears it is twinkling because of the atmospheric refraction. But planets do not twinkle because they are nearby to us. That effect will be nullified there. Then apparent distance of the star from us is more than compared to the actual distance. That is also due to atmospheric refraction. And 2 minutes earlier, we see the sunrise, and 2 minutes delayed, we will have the sunset. This is also due to atmospheric refraction. Okay. Next, about the next phenomenon, it is about scattering of light. Okay. Netra, can you tell? Netra, can you tell what is the difference between scattering of light and the reflection of the light?
Scattering of light is when it spreads out in opposite direction.
So when light falls on any object, so if the surface of the object is rough, it will scatter, light will scatter in all the directions. That we call it as scattering of light. Scattering of light means what? When light falls on any object, it will scatter on all the directions. Light will scatter on all the directions when it happens, when the surface is rough. But when in a mirror, it is a reflection because it comes in a particular direction and image will be formed there. So there we see the reflection. Now we will study about the phenomenon of scattering of light. Okay. So we studied about Tyndall effect in 9th standard, correct? Colloidal solutions will show the effect of Tyndall. Tyndall effect can be seen in colloidal colloidal solutions, we see the Tyndall effect. So, what is the Tyndall effect? When particle size is enough to scatter the beam of light. When particle size is enough to scatter the beam of light, we see it will scatter, and we can see the dust particles in the air, mist in the air, because it will scatter the beam of light. But in a sugar solution, it is the solute or the particles are so small that it will not scatter the beam of light. It's correct. That we call it as Tyndall effect, what we studied in the 9th standard. Okay. So the sky appears blue, correct? The sky appears blue. Why it will appear blue? And we have white light has the rainbow colors, all the Vibgaya colors are there. So red is having the greater wavelength and blue is having the smaller wavelength, correct? So red wavelength, if the wavelength is more, then the particles should be, size of the particle should be more to scatter that larger wavelength light. Okay. So again, I repeat, white light has 7 colors. Okay. White light has 7 colors. So red is the most having the highest wavelength, whereas the violet is having the least wavelength. Blue also comes nearby to that. So if the particles want to scatter the red light, its particle size should be more, because if the wavelength of the light is more, the particle size should be more to scatter the light. Okay. So blue light is having less wavelength. Blue light is having the less wavelength. So in the atmosphere, we have more fine particles. In the atmosphere, we have more fine particles, and blue light is scattered most. Okay. In the atmosphere, the fine particles are more. So they will scatter the blue light more. That's why the sky looks blue in color. Okay. So see how we can see the color. See which color it we receive from anything, that we can see. White means it will reflect all the colors. Mixing, we will get the white. Black means it will absorb all the color. That's why it looks black like that. So which color we are that enters our eyes. So because of that, we can see that color. Okay. So white light has all the colors, right? But the fine particles will scatter the blue light most. Why it will scatter the blue light most? Because the particle size is less. So it can scatter only the lower wavelengths light. So that's why they will scatter the blue light more. Hence, sky looks blue in color. Okay. But in the morning, if you see, the sun looks red in color, correct? The sun looks red in color even now, but we know that it is white because it emits white color. But why it looks red in color? In the morning, when it is coming from the horizon, it is at very far distance from us. At that time, it is at very far distance from us. So all other light will be scattered away from the particles. That is, they will be scattered away from us. Okay, the light which reaches our eyes is only the red light. When the sun is very far, especially when sunrise and sunset time, the sun will be very far from us. Okay, at that time, only the light that reaches us is the red light. Fine particles will be more, right? So they will be started away from us. Only the red light can reach us. That is why it looks red in color. Okay, that is why during the sunrise or sunset, it looks red in color. And during the afternoon, the sun will be above our head. They tell us, no, it is above the head. That means what? It is very nearby to us. Sun will be very nearby to us. That's why the sunlight is also very sharp during the afternoon, 12 p.m. and all. It is very sharp, right? What is the reason? Because it is sun is very nearby to us. So at that time, we can see the complete white light. See, in the morning we see sun as red. In the 12 noon, it sees as white color, correct? But the color of the sun will not change there. But still, it looks like that. What is the reason? At the sunrise or sunset, it is very far from us. So, in the white light, only the red light will we will be able to get to our eyes. So, we can see only red. But in the afternoon and all, it is very nearby to us. Sun is very nearby to us. So, most of the colors we are able to see. That's why it looks white. Okay. So all these different colors, what we see, it is due to scattering of light. And in the scattering of light, if the wavelength is more, then it need more bigger particles to scatter. If wavelength is less, even the fine particles can scatter the wave.
So the body there are bigger.
No, it is very far. From to reach, before reaching us, all other light will be scattered away from us. So only the red light will be not scattered away from us because it is not possible to scatter that.
Okay.
That is reason it will be like that.
Now what is the wavelength of
White light. Don't know. I'll just check. It is a combination of colors, and we should.
And sometimes the sky is pink. Sometimes it looks orange, right?
It's the same reason. It's a mixing of the colors what we see. Because of that only we see.
What color can be it
Looks like.
What is it?
It's itching paper. Huh. Write down this. Scattering of light. One AP question also we have left over, no? That also will finish it up. If possible, time we should finish that. Scattering of light. So the reflection of light from an object in all directions, is called scattering of light. It is called scattering of light. The color of scattered light depends on size of scattering particles and wavelength of light. Right down color of the sky is blue. During daytime, sky appears blue. This is because the size of the particles in the atmosphere is smaller than the wavelength of visible light. So they scatter light of shorter wavelength. The scattered blue light enters our eyes.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.